assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So, for naming coordination complexes, we need to follow the steps or rules mentioned here. So, first we have to start with the cation or the cationic complex while writing the name, and then we have to write this anion or anionic complex. And while naming the complex, so inside the complex, we have to start with a prefix like di, tri, tetra, or for complex ligands like in which ligands they have di, tri, or tetra within their name. For that kind of complex ligands, we have to use bis, tris, tetrakis, and something like this. And these are for to indicate the number of ligands present in this complex. And then if we have multiple ligands, we have to arrange them in alphabetical order. And finally, we will have to write the central metal atom or ion name. And we have to write its charge. For example, if it is +2, we have to finish by writing it in Roman numeral like this for 2. For charge 3, we have to write this. For charge 4, we have to write this, and so on. So let's go to solving the first one. So here we have copper as the central metal atom, and then we have 2 ethylene diamine ligand. So let's start with the prefix of the ligand, and since it's a complex ligand, or this ligand itself has diamine in its name, so for 2 ethylene diamine we have to put bis, and for this bis, tris, tetrakis, this kind of um, prefix, we have to put the ligand name within a round bracket. So bis ethylene diamine, and then we have the central metal atom as copper, and we have +2 charge on copper. That's why we'll have to put 2. Okay, and then let's go to the second one. So here we have manganese as the central metal atom. We have 3 carbonyl groups and 3 nitro groups as ligands. So if we arrange the ligands in alphabetical order, we have to write carbonyl first and nitro later. So start with the carbonyl group. We have 3 carbonyls, so we start by writing tri carbonyl. Then we have 3 nitro groups, so trinitro. And then we have the central metal atom manganese. And the charge on manganese here is 5 plus 5. So you can calculate the charge on the central metal atom by a formula we have already covered in the previous problem. Some tricarbonyl trinitromanganese 5. That is the name for this complex. And then let's go to next one here. So here we have 2 part of a compound. First part is a single sodium cation, and second part is an anionic complex. So we have to start by writing the cation name. So it is sodium, and then we have to name this anionic complex. First we have to uh, write the ligands with their prefixes. So is since water is named in complexes as aqua and OX as oxalato. So we have to put aqua first and then oxalato in alphabetical order. So we have sodium diaqua. Then we have, so this oxalato group is also a complex ligand which has a di in its name. So we have to put bis for oxalato. Bis, we have to put the oxalato name in the round bracket. Bis oxalato. And then we have our chromium, which we write as chromate. So sodium diaqua bis oxalato chromate. So this is our name for this complex. And then for the last one, we have two complexes put in the compound. First one is the cationic complex, and the second one is an anionic complex. So we start by naming the cationic complex first. So we have three ethylene diamine group, and since it is a complex ligand, we have to name these three ligand as tris. So we start by tris, we put the name in bracket, diamine, and then we write our central metal atom cobalt, and cobalt has a +3 charge here, so to write 3, and then we start naming the anionic part where we have 6 cyano group, so we write hexacyano, and we finish by writing the central metal ion name, which is ferret. And this iron has also +3 charge, so we write 3. That's a name for our coordination complex here.